So this is your first video of the year made by me. Let's see if I remember how to do it. So the first question is 44 or 141, no, 14,124 divided by 44. And let's just follow the standard procedure. It does not go into 1, but it does not go into 14, but it goes into 141. I'm going to say 312, 112, 3 times. You don't need to write those x's, okay? Actually, it's probably better not even to write it, as long as you know where, what place value to write the 3 on top. So in this case, we're doing a 141. 3 times 4 is 12. Carry 1. 3 times 4 is 12 again. Plus 1, 132. Let's subtract. So it's 141, a little borrowing, that becomes a 3. 11 minus 2 is 9. Bring the 2 down. 44 goes 92 2 times, because 44 times 2 is 88. So 2 over here. And 88. Let's subtract that. Borrow again. 12 minus 8 is 4. Bring the last 4 down. And it goes 1 time. 44 goes to 44 once. Okay. If you wanted to check, you could take a couple of seconds here and multiply 321 times 44. Okay, so you get 4, 8, 12. Then this 4 you add a 0 because you want to move it 1 over to the left. 4 again. 8 and 12. 4, 12, 11, 4, 1. 1, 4, 2, 4, and you see our value is exactly the same as the one we started with. Okay. All right. So I'm just going to move the screen down. 25, 1,034 divided by 25. Again, let's pick something else. Purple. 25 does not go into 1, does not go into 10, but it goes into 103 4 times. Okay, so I write the 4 on top of that 3, and it's 100. Okay, subtract 103 minus 100, you got 3 left over. Bring the 4 down. 25 goes in 34 once. 25 times 1 is 25. Subtract, a little borrowing again. 14 minus 5 is 9. That's your remainder. So your answer here, you can write it as a, leave it like that. Remember 9, or if you write it as a fraction, better yet, it's 41. 25 goes into 1,034 41 times, and then 9 out of 25 again. Okay, your check, if you wanted to, 1,034 times 25. Okay, so 5 and 4 is 20, goes 2, 15, 17, and 5. Move on over. 2 times 4 is 8, 2 times 3 is 6, 2 times 0 is 0, 2 times 1 is 2, 0, 15, 8, 5, 2. Don't forget we have to add that 9 there, plus 9, and I'm doing something wrong. No, I should have multiplied, sorry. 41 times 25. I have no idea why I'm multiplying those two. My apologies. Let me just go back. Good thing I checked. So here we go. It's 25 times 41. Sorry. So that's 25. 0. 4 times 5 is 20. Goes 2, 8, 10. If you add this up, 1025, and we're going to add that remaining 9. And if I add 1,025 plus the 9, I will get 1,034, which is what I started with over here. Okay, so if you notice, we're using the standard algorithm. Okay, it's a more popular way of dividing. So divide, okay, multiply, subtract, bring down. Okay, just repeating those 4 steps until you get to the last number. Okay. Let me scroll down. Use the rainbow or T-chart method to find all the factors of the number. Then circle whether the number is prime or composite. So, I like the T-chart. I'm not too sure about the rainbow because it gets really messy. Okay. Like I told you in class, nice if you do it in order. Okay. Start with 1. 1 times, obviously, 99 is 99. Will 2 go in? Is there a 2? Is 2 a factor of 99? So 2 doesn't work because 99 is not an even number. But 3, does it work? Well, 9 and 9 is 18, and 18 is divisible by 3, so definitely 3 will work. So it'll be 3 and 33. No 4s, no 5s, no 6s, because 2 didn't work. No 7s, let's see. 7, no. No 8s. 9 will work. Okay. You can add 9 and 9, 18. Divided by 2 is 9, so you know it's going to be, what do you call it, divisible by 9. 9 and obviously 11. And that's about it. So, determine if it's prime or composite. Well, I have 1, 2, 3, 4, 5, 6 factors, which definitely makes this a composite number. 36. Again, T-chart. You know what? This one, just in case anybody out there wants to do the rainbow, let's do the rainbow. 1 and 36, and just make sure that you spread it out. Okay, because some numbers definitely have a lot of factors. 136. 2 and 18. Let me put a comma here. 3 also works. It would be 3 and 12. 4 also works. It would be 4 and 9. And we have 6 and 6, but I'm not going to repeat until. And you can tell this has a lot of factors. So this is definitely also a composite number. Okay, so notice I didn't do that rainbow thing here on top because it does get a little messy, but you get the idea. Okay. I am moving. So there you go. We did this in class on what they say Wednesday. So some of you might remember this from class. You want you to determine if the number is a prime composite and a MERP or a perfect square. 4 is definitely composite, so you can write just C for composite. Is it in a MERP? No, it's not prime to begin with, so definitely no. Is it a perfect square? Does it have two factors that are equal? Equal when multiplied, that gives 4. It does 2 times 2, so it is a perfect square. So you can write yes. 31 prime or composite? It's prime because 1 times 31 are the only 2 factors, natural numbers. No other numbers multiply give you 31, so that gives you prime. Is it any MERP? Well, it's prime, and if I switch 31, it becomes 13, and 13 is also prime, so definitely a yes here. Perfect square? Nope. No 2 identical numbers multiplied will give you 31. 99 prime or composite? Well, it's definitely composite because it has more than 2 factors. It has 1 times 99, it has 3 times 33, it has 9 times 11, so a lot of factors here. Makes it a composite. A MERP? Nope. Not even a prime to begin with. Nope, nothing to worry about. And definitely no 2 numbers that are liked. That will give you a product of 99. So this is a no as well. Okay. Let's scroll this down a little bit. Let's clear the page. Okay. So now this one might take you a little bit, but if you are familiar with the divisibility rules, it shouldn't take that long. Definitely 2. Check. It's divisible by 2. 1056 divided by 2. This is a no. Okay, so I only want you to put a check on the ones that actually match. Is 466 divided by 3? Well, 4 plus 6 is 10, plus 2 is 12, and that's divisible by 3, so yes. Rule for 4, I'll check the last 2 numbers. 4 goes, that's a no, so leave it alone. It's not, doesn't end in 0, 5, so no. 6, did it work for 2 and 3? Yes, let's check. Excuse me. 7, double the last number, so you have 462 over here. Double this number, it's 4, and subtracting from 46. And 46 minus 4 is 42, which is a multiple of 7, so definitely here. 8, you have to actually divide it by the last for the last 3 number, which is 462. Anyway, so and I'm going to say it's a no because 8 goes into 46 5 times 40 and leaving you a remainder 52, and 8 doesn't go into 52 even. So 8 is a no. 9, if you add them all up, 4 plus 6 plus 2 is 12. That's not divisible by 2. 10, it's not. It doesn't end in 0. 11, remember what we had to do. 4, 6, 2. So 11, add this one. Who is this one? 2 and 4 is 6, and then subtract it by the other one, giving you a 0. So if the answer is a 0, or any other multiple of 11, it's divisible by 11. So in this case, definitely yes. And then 12, is it divisible by 3 and 4? Yes for 3, no for 4, so it's definitely not. Okay. 1056, let's see, add them up. 6 plus 5 is 11. 12 divisible by 3, good. That checks. 4, the last two numbers are divisible by 56. Okay, put 4 going to 56 14 times. 5, no. 6, yes, because it worked for 2 and 3. 7, double the last one. So it's 1056. Double this last number, it becomes a 12. Let's subtract it from 105. 105 minus 12, that's going to be a 3, and then borrow 9 minus 1, 83. 83 is definitely not a multiple of 7. It's not going to work. Let me just erase this again. For 8, look at the last three numbers. It's 1056. The last three numbers here being from 1056. Look here. It's 56 divisible by 8. Yes, it is, so it's going to work. For 9, add three numbers again. 6 plus 5 is 11, plus 1 is 12, not divisible by 9, so that's not going to work. 10 doesn't end in 0. 11, so we want to add this one with this one, so 6 plus 0 gives you 6. And you want to add the second one and the fourth place, which is 5 and 1. That's going to give you 6, and if you subtract those, it gives you 0. Again, remember, a 0 or any multiple 11 makes 1056 divisible by them, so that's a check. 12, did it work for 3 and 4? Yes, it did, so there's a check there. 647, okay, I know this is a little bit long. 647, not even, not going to work. For 3, 6 plus 4 is 10, plus 7, it's not going to work. For 3 as well, not going to work for 2 because it's not even. 4, no way because it ends in 7, and the last two are not divisible by 4. 5 is a no, 6 is a no. 7. So 647. Let's double the last one. That's 14. And subtract from 64. 64 minus 14. We can do that in our heads. And that's 50. No. 8. Well, no, because I know that 8 doesn't have any multiples that end in 7. So that's a no. 9. 6 plus 4 plus 7 is 17. It's not going to work. 10 is not going to work. What about 11? Let's see, 13. No, 11 is not. So 11 is 647. You're gonna take 7 and 6, add 13, subtract by this one, minus 4, and you're gonna get a 9. So that's not gonna work. And 12, not gonna work that either. So 647 is a prime number. Wow, didn't work for anyone. Okay. This is the first 10 prime numbers. First prime number, please. It's a 2. Second one, a 3. 5, 7, 8, 9, 10, 11, 13, 14, 15, 16, 17, 18, 19, not 20, not 21, 22, 23 is prime, 24, 25, 26, 27, 28, and 29. Here are your first 10 prime numbers. Okay. Let's clear this, lower this. This prime factorization of 360, so you can use the 3 factor. Okay, so look for two numbers that multiply, give you 360, any two. Okay, you will always get the same response, so I'm just going to take the easy one. I know it's 36 times 10. Okay, they're both composite, so I know I can break 36 further into 6 and 6. I take the first 6 and break that into 2 and 3. 2 is prime, so I can circle it, which tells me I can't break it up anymore. 3 is also prime. The other 6 breaks the same way. You've got 2 and 3 again. Let's circle the 2 because it's prime again, and 3 because it's prime. 10. Let me continue. 10 is 2 and 5. Circle the 2 because it's prime. Circle the 5 because it's prime. You've got to break the number. If it's composite, you can go further. So another way of saying 360 using only prime numbers, it's 2 times this 2 times that 2 times this 3 times that 3 and times 5. So we are rewriting a composite number as a product of prime factors. Okay, we're going to changing 360 and rewriting it, okay, using multiplication of all its prime factors. So one way of saying it, it's 2 times 2 times 2 times 3 times 3 times 5, or better yet, in exponential form, 2 to the third power times 3 to the second power times 5. Okay. And finally, the last question. Let's see. I don't even know the answer to, because I just made it up. A number that's 4-digit number that's divisible by 2, 3, and 5, but it's not divisible by 8. Okay, so I know that it has to end in a 0, because if it has to end in a 0, or maybe a 5. Oh, well, no, because it has to be divisible by 2, so it has to be an even number. Okay, so 0, 2, 4, 6, 8 are my choices, but because 5 in there has to be 0. Okay, if I put a 5 here at the end, it won't be divisible by 2, so 0. Now I know it has to add up. Okay, the sum of all these digits had to add up and be divisible by 3. So you know what? This is very easy actually. 1, 1, 1. Is it divisible by 2? Check, because it's an even number. Okay, is it divisible by 3? Check, because if I add all the digits, 1 plus 1 plus 1 plus 0, it's 3. And it's 3 divisible by 3? Yes, it is. Is it divisible by 5? Check. Why? Because it ends in a 0. So that wasn't that bad. Okay, so this is your review. I always give you guys extra points for watching the video. So, but I need proof that you actually watched the video. So your proof is going to be on Friday to wear mixed match socks. In other words, socks of different colors. Okay, and that's your little proof for me. Okay, that's it. We are done. Once I find how to turn this off, and here we go.